Okay, welcome back. Um, this is a program where I will teach you some basics and also some shortcuts. So firstly, if you see here, um, this is the title we write. The title is to be written here. This means what this program is all about. You could write about this program. This is like a comment, but comments are different in assembly language. We can put comments. For example, I want to comment that this is the data segment, so that is like this colon, and then you can write anything, whatever you want, like print this message, whatever. So this is a comment. That means this will not be taken up by the assembler later on. This is just in your source code, because whatever you have written is called, this file is the source code, and then we have to assemble it, because computer will not understand this English language. It understands only zeros and ones, so we have to assemble this program later on. Not only assemble, but also to link. Now if you could see here, I will go quickly to this. We have the segments. This is the data segment, and this is data end. S means end segment. Now there's a code segment, and this is a code ends. Basically our memory is divided into the segments. Better I will show it here a little bit. For example, this is our memory. Oh, it's not writing. This is our memory. For example, we have basically 4 segments in it. 1, 2, 3, and 4. One for the data, so maybe this is a data segment, and then one for the code segment, and one is for the stack segment, and one is the extra segment. So your data, whatever data you will put in here. So this, for example, this message was a db, that means data byte. We could say dw, data word, that means it will be having words assigned, all of these characters J, U, and they will occupy one word. But it's a data byte, that means each character will occupy one byte, that means 8 bits. So we could have many others, like code word 10 bytes, like that, that you will see from the book. Now you see here I have defined a message here with the data byte. This is the message, and this message, because this is in a data segment, so this will be in this segment DS, and whatever code I will write, that code will be occupied in this code segment. Okay, and if I have a stack, something to be stored on the stack, which we'll see later on, we need stack all the time, that will be put here. And if there's also some other things we will use later on, that's up to the programmer's discretion, that will be put in here, extra segment. But extra segment can be used for multiple things, but data segment will be used for only data, code segment for the code, and stack segment for the stack. Now the beginning of the addresses, where from, this data segment has some starting address, some ending address. Okay, basically we have 4 these segments in a memory. We could have more than 4. Means I have data segment, I could have 2 data segments, but at a time only one will be active. So we can have more than 1 segments. So these segments I'm talking about, this is a memory, the RAM, you could say. But this data segment will have some address, code segment will have some address, stack segment will have some sorry, stack segment will have some address. Those have to be stored into the segment registers. What we have learned in the last video, that we have stack segment register, we have data segment register. So these where from the data segment starts have to be stored in the register. Similarly, with the code segment starts, have to be stored into the register called code segment register. So that's what we are doing here, is a code segment. Then we are saying assume CS is to code, DS is to data. First we have said this data is actually the data segment, and this code, what we have labeled, we could have put anything else. We could have say any name. It's not necessary you put code here. Anything. This is a usual way of writing things, but we could write anything here. That what we have to link it with the DS. That we have to say data is to data. If we say here beta or meta or your name or Juni, but we have to say DS is to Juni to link it. So this is immaterial what we write here. Getting it or not? So next thing is this thing, the data. This is the first start label. The start label is important because this tells the assembler to start right from here. That means your code starts from here. We have to write the start and end the program with the end start. Okay. Also, we have code segment basically here, and its end code ends. End segment is here. So this is all the code segment. First thing is the assume, that we have to assume that this data is for the data segment, and this code CODE what we have written here is for the code segment. I told you that we could write here anything else. Now second thing is we have to say, for example, we said move. This is the first thing which you will see in all assembly languages, that put this data into the AX register accumulator, which I have explained in the last video, and then put this AX in the DS. So what we are basically doing is we are putting the address of data. Sorry, not this one. This one. This is a data segment. Okay, we are putting the address of this data segment, this address, into the DS register. This one. This is the DS register. Okay, we are putting in here. Why don't we put directly data to the DS? But we cannot do direct memory allocations to the segment registers, so we have to use some general purpose register. So AX accumulator is the general purpose register, so I put first data into the accumulator, then accumulator to the data segment. Okay, so we could do it like that. So are you getting me or not? So what I am telling you is we have to first, this is the code what we call as boilerplate code. This you will see in all assembly languages, where we have to put the data segment into the DS. We don't use this thing for the code segment, but we have to use this thing for stack segment as well as for the extra segment. Code segment is initialized as such. So data, if you have data segment, if you have stack segment, if you have extra segment, we have to initialize it like this. We have to put data into the AX, then AX into data segment register, DS register. Similarly, we have stack segment, we have to put stack segment into some, maybe AX, and then AX into the SS stack segment. Similarly with the extra segment. Now next thing what I will do is I have to print this message. How I will print this? We have actually in the assembly some interrupts. This is the DOS interrupt call. This int21h is the DOS interrupt call. We are calling actually the DOS, and when assembler sees interrupt 21h, it will see at that time what is in a AH, and at that time AH is 09h. This means you're gonna print something. The 09 is a function which is for printing a string actually. So we have to load the message, its address, because this message will be somewhere in the memory. So this message will be somewhere in this data segment, in somewhere here, maybe here. So it will have some address here. This is the message I will have written here. So this will have some address. This address is to be loaded first in some register. So we load that in what? In the DX register, because interrupt 21h's function 09h works on the DX register. So we have to load this into the DX register, then it will be printed. And this is to exit. You have to put in AH register 4CH. This is again the interrupt 21h call to get back to the DOS. This is to say goodbye. And then code ends and end start. And if we run it, I have already linked it. So I will say this was intro. So let's say for STASM, if you want to assemble it, intro intro1. So then we link it, t-link intro1, and I will run it. So that's it. Juni teaches assembly step by step. That's all for this program.